So yesterday I have solved the error, and I just thought of showing you the program today. And guys, here let me show you that. See, whenever we are working with the natural language processing, NLP, okay, it is a subject where we will be completely working with the words, and where we need to classify, and where we need to split the words. See, splitting the stop words, identifying the stop words, we have already seen yesterday, okay, and understanding how much accurate it has done that proper work. Why? Because what are the things that we need to analyze in natural language processing? Let us talk in real time. If at all, if you are thinking about the natural language processing, definitely where we are trying to implement very first thing, we will try to implement the natural language processing wherever there is a speech recognition very first time. I mean, very first thing. And the very the second thing is wherever we have a lot of text data that we are required to do the text analytics or text mining sort of stuff, with the help of the understanding the behavior of the reviews or the comments or the posts made by the public or the customers. So there are two different types of implementations. In whatever the implementations, the something is common. Okay, something is common here is nothing but understanding the words inside the language. Okay, how can we split those words? And then grammatical sentence understanding is how the grammatical understanding is. So we have several methods and several libraries in the natural language processing, out of which that we are looking after a one program regarding with the natural language processing. This program clearly defining the work of stop words, understanding the stop words. Okay, so picking up only the stop words from the respective reviews is very much important, that is I feel. So here, this is what that we have done here. We could clearly see the stop words, whatever we have created. Splitting the data. Okay, you might see the spelling mistakes, and we should understand however that they have given the words. Okay, we need to be able to understand what exactly will happen. So in order to understand the words that was representing in these particular statements, we will have something, a model called a bag of words. Okay, I will tell you, this count vector is the one which we will be using in the bag of words model. Bag of words in an NLP. Okay, so this is the one where we will use to represent, or we will use this one in order to retrieve the words from the given data. Okay, you could clearly see that this model will be represented as a multiple set of words, okay, and without not respective towards the grammar or whatever it is, okay. So this is generally called as a bag of words model, okay. Here in the Python we have something called count vectorizer, okay. Count vectorizer is the one where we are using it in order to work with this to get the words from all the different statements. So the mistake that it was done yesterday is there was a wrong variable which was assigned, and hence we are unable to make it up in the yesterday session. And in here, I have just resolved it, and finally, you can see that we are trying to use the navy base, and you could try understanding the predictions over here. And finally, we could see the model, how well it worked. Not only the Gaussian or the navy Bayes model that we can implement over here to understand, okay, but also the some other stuff, whatever the models, classifier models that you can implement the logistic, okay, also even. So you could see, can you tell me how much is accurate is this one, this model? Guys, let us try calculating this part. It was, how much is it? 55 plus 91, 146, 146 plus 12 plus 42, 200. So 146 divided by 200. So it is 73% accurate. Okay. You can also even try applying you can try this as an exercise. Okay. You can please try to import the logistic regression. Okay. And try using the classifier for the logistic regression over here, and please go ahead with the confusion matrix, please. Okay, you can take this one as a exercise for you, and you can try identifying how much is the accuracy that you have got by using that part. All of you understand this part? So today let me discuss about the neural networks. Okay, let me discuss about the neural networks. Okay guys, now let us go ahead with the neural networks. So generally, this neural network concept we will mainly rely on in order to understand the or classify the image. Okay, image processing. So how these neural nets are going to help us in order to do the image processing? Let us understand. Here, before we are going to understand about the neural networks, we need to understand that neural networks has been taken completely from the human way of understanding an image. Okay, so biologically, whenever we are looking at one particular image, how the signals have been sent to the neurons to understand the respective color and the size and the object which is displaying in the image. So using the same biological understanding, and converting the biological understanding into a mathematical model. And from that mathematical model, we are going to build something called the neurons. Okay, now let us see. Generally, this is how the neural net structure will be. Okay, so whatever the input vector that you are sending across, that needs to be get processed with the various computations in the middle, and then it will finally give you an output respectively. Okay, of course we need to do the training, proper training, okay, without which that it cannot learn, okay, how exactly it needs to carry forward the processing. It is obviously a bit complicated computation when it is compared to the regular machine learning algorithms. Okay, in order to understand the data, which is going to be a final output, it needs to come from the very basic data that you are passing through that one for getting the training for that neural net structure. Here, this is the very basic neuron visualization that I'm talking about. We will have something called an activation function where you are using the data from previous layer and you are trying to use this activation function to get the something as an output, and hence the some form of the computation transform whatever the inputs that you have given, and finally that will be transferred, that will be transformed into the neuron, which will give you the output data as a transformed data. See here, we are calling something called weights. Okay, each and every subjective variable x1 and x2 and x3 will be having certain sort of weights, w1, okay, w2 and w3, okay, different weights. And here you could understand the loss function. Here we have z is equal to x1 w1 plus x2 w2 plus x3 w3 plus b. Okay, so this is how the vector notation. So z is equal to net input and b is equal to bias, whatever that you are going to get, and f is equal to activation function. So a is equal to output to the next layer. So this is the basic formula that we could understand from the neural networks. So here, generally, in relation to the logistic regression, generally what we do have 1 divided by 1 plus e power minus z. So our z value, we know that it is all about x1 w1, x2 w2, and till plus bias. So hence here it is nothing but a neuron is simply a unit of logistic regression clearly. Right? Understand it, a neuron is a very small thing, okay, or we can understand it as a very small entity of logistic regression. Okay, so here we are using a neuron which is going to be a unit of logistic regression along with some weights and coefficients and biased, which is going to be a constant. Till now so far what we have thought, we have named them as coefficients. What is that, guys? We have named them as coefficients and weights. Okay, here we have something called input variables, inputs as variables. This is what we have thought. Okay, till now so far, we worked on many machine learning algorithms, okay, in which we have always thought of coefficients, variables, and constant terms, constants, which we have used. Here we are calling them as bias, weights, and inputs. Okay. So guys, we should be clearly able to understand the sigmoid function. The sigmoid function of the logistic regression. Okay. Here, when we are trying applying the derivations for the same, okay, so which is going to be something like this, where you will be trying to understand once after the derivative of this particular sigmoid function, which is getting resulted into e power 1 divided by 1 plus e power minus z into 1 minus 1 divided by 1 plus e power minus z. How you got it? We know the coefficient rule, and this is the general derivations that we have applied for the sigmoid function, and where we can always try applying the same and by deriving by using this derivation of this formula. Okay, now the sample neuron computation, how we are trying to use, we are just mentioning it as a sigmoid function, activation function, and we are trying to convert that part. And you could see that I have different values over here: zero point 0.9, zero point 0.2, zero point 3, and 1. Okay, and here I have different weights: 2, 3, minus 1, and zero point 0.5. Now let us understand. So if you calculate this one, we have got a z value is equal to 2.6. Now the same 2.6, let us try understanding a function. A function is equal to the sigmoid function f of z is equal to f of 3.5, which is going to be a 1 plus 1 divided by 1 plus exponential of minus 2.6, which is becoming 0.93. Okay, so now neuron is having an output value as 0.93. Okay, this is how that generally we would calculate about the function. Okay, sigmoid function. So here neuron output value, see, you can see like after a lot of computation it is giving you a one single value. Tomorrow I will explain you about the convolutional neural networks. You will understand little bit more guys about this part. Okay, which is going to be used for the image analysis that we will see in the tomorrow session. So for now let us understand few more things about the neural networks. So here, why are we not using a single neuron? Why do we need a larger network of the neurons? This is a very important stuff here. We need to understand. Okay, so a single neuron, like a logistic regression, will permit a linear decision boundary. Okay, so we require a network of neurons. Okay, a single linear boundary, that is what a logistic regression will provide us basically. Okay, in the same way, a single neuron will provide, it's a fraction, right? A neuron is a fraction, right? So here, this is the feed forward and back propagation. We have two things to understand from this one: feed forward neural network. The first one is a feed forward neural network. In the feed forward neural network, you could observe each and every particular input variable will be associated with the one sigmoid function. Okay, and we will make in a relation between all the sigmoid functions, n number of sigmoid functions that you are trying to apply. We will try to map all these weights to the n number of sigmoid functions, and thereby each and every sigmoid functions will be mapped again with the rest of all the sigmoid functions, and finally all the sigmoid functions has to provide the respective value to the output variable by default in the same way again. Understand? So now you could see the way that relations, how it is being dealt. Here the input layer, this is what the input layer, and you are seeing that both of these two sorry, they are not output layers, they are hidden layers where the computations are being done in the background for all those functions that we are creating. Okay, and this is the output layer. So here, whatever the weights, each and every point that you could see, that weights can be represented by the matrices what we are trying to apply over here. So here, the net input of sum of weights inputs before activation functions. So for before you are going to applying an activation functions, there will be some net input. Okay, so here something called an activations. Okay, and where which will become the output of neurons, which can be carried away the activation values to the next layer. So here you can clearly understand the matrix representation of the computation. I will show you the matrix computation of, matrix representation of the computation in the convolutional neural networks in the tomorrow session. Okay, you will have a more clarity about that part. Okay, so now let us see. W1 is a 3 by 4 matrix. Z square, Z of 2 is a 4 vector. A of 2 is a 4 vector. This is a general matrix representation when you are talking about the weights. Okay, 3 inputs and 4 functions. 3 by 4 means each and every input variable needs to contact all the three input variables. Each and every one particular variable has to contact with the respective sigmoid functions, all 4 sigmoid functions over here. So this is going to be a 3 by 4 matrix. Okay, and z of 2, where you are trying to get what, see, where you are trying to get net input. Okay, once after the processing of this one, z of 2, once after the processing of this one, before you are going to send it to an activation, before the activation function is going to happen, some of the weighted inputs 4 vector, and this is a 4 vector. Okay, so this is all for a one particular training instance. Okay, this is all going as a one particular training instance. Hence we are going to see the multiple data points over here, which is inputting as a matrix, and where you are getting an output as a vector, single predictions. Okay, understand guys, all of you? So this one we will discuss about the convolutional neural network, and with one example of the image recognition in the tomorrow session. Okay, we will meet again tomorrow, and we will discuss about the artificial neural networks related convolutional neural network, and with one example. See you all, thank you.